Alright guys, today you are going to be continue on working on the Pythagorean theorem, but in order to do that, let's take a look at a warm-up question this morning that will make sure you still remember how to do this, okay? It says, Lily is building the large number cube as shown below. She connects a metal wire from point X to point Y for support. What is the length of the metal wire rounded to the nearest tenth of an inch? So, if we take a look here, we can see that this is a cube, so that means all of the sides have to be the same. So when you look at it a little bit more closely, you might notice that if we start highlighting some things, we have that shape that we've been looking for in most of the problems. So look here for X to Y, and then over here at 12. Sorry, my triangle is not perfect, but you can tell that is going to be forming a right triangle right here. So the hypotenuse is going to be our missing side. We know that the base is 12, and we know that the height is also 12. So to get your answer for this, just as a reminder, a squared plus b squared equals c squared. So the legs are both 12, and the hypotenuse is the unknown. So take a moment right now and see if you can simplify this to come up with the correct answer. Alright guys, so now that you're ready to go, if you simplify 12 squared, that's 144. So you're going to have 144 plus 144 equals x squared. When you add 144 and 144 together, you get 288 equals x squared. Remember, our goal is to try and solve for x, not x squared. So you have to square root both sides. After you use that double arrow button to get your answer in decimal form, it works out to be like 16.97. But the directions say to round to the nearest tenth of an inch, so it's one place after the decimal point. The 9 bumps up to a 10, and the 10 makes the 16 now a 17, so the correct answer for this is B, 17.0. Today what we're going to be doing is we are going to be doing actually the opposite of the Pythagorean theorem. So far you have known that the triangle is a right triangle, and because now we had a right triangle, you can use the Pythagorean theorem to find any missing length. Today what we're going to do is called the converse of the Pythagorean theorem. It kind of flip-flops everything around. So the essential question is, in what other ways can we use the Pythagorean theorem? So take a moment right now and copy down the title of the lesson and the essential question. If you take a look at the screen underneath the essential question, it says what a converse is. Converse is just flip-flop things around, okay? So it says the converse of a statement switches the hypothesis and the conclusion. So if it started out like, if it is sunny outside, then it is 70 degrees. Let's say I substituted that in. Okay, so if it is sunny, then it is 70 degrees outside. The converse would be, if it is 70 degrees, then it would be sunny outside. Not necessarily true, but just showing you how that would work. All right, so we know what the Pythagorean theorem is. A squared plus b squared equals c squared. That works for right triangles. Here's the flip-flop. We're saying if this equation holds true, then you can prove that you have a right triangle. So that is the difference. So now if this holds true, then you can decide if it's a right triangle or not. So if you take a look at the two triangles that I have, it says tell whether each triangle is a right triangle. So they're giving us all three sides. What we're going to do right now is check to see if Pythagorean theorem works. And if it does work, then you found yourself a right triangle. So always look for the longest side to be your hypotenuse, okay? So this would definitely be side C. All right, so we're going to mix up the other numbers as much as we want. So it would be 9 squared or 40 squared. You can mix those guys up. So 9 squared plus 40 squared. We want to check to see if that actually equals 41 squared. All right, I know 9 squared is 81. If you do 40 squared is 1,600. And then 41 squared is 1,681. We're checking to see if these equal one another. Well, if I add 81 and 1,600, I am going to get 1,681. That does equal 1,681. So because these two numbers equal one another, we can say yes, right triangle. So that's how this is a little bit different. You're proving with the numbers that you have a right triangle. So if we look at B, for example, and I'll switch up the colors, all right, the longest side on this one is 24, so that would have to be our hypotenuse. So I'm going to say 18 is a leg and 12 is a leg, and I'm checking to see if this is going to equal the longest side squared. So again, I'm not sure that these are going to equal one another. All right, so using my calculator, 18 squared is 324. 12 squared is 144. And I'm again checking to see if this equals 24 squared. All right, 24 squared is 576. So if I add 324 plus 144, I find that it only equals 468. So 468 does not equal 576. So therefore, this is not a right triangle because the two numbers do not equal one another. So not a right triangle, and you can abbreviate. All right, let's take a look at the two on your own questions. This time they don't have a picture, but we remember that the longest side has to be our hypotenuse, or side C. So if we look at question number 1, this would have to be your hypotenuse, so set that all by itself. And in the next three numbers, you're going to have that the 1.25 would be all by itself. So take a couple moments right now, and it might be a good opportunity to pause the video to check to see if you can use the converse of the Pythagorean theorem. All right, guys, so up here on the board are the answers to the two on your own questions. If you set up the Pythagorean theorem with the legs, 21 squared plus 20 squared equals 28 squared. Simplifying everything down, you get 441 plus 400 equals 784. When you add 441 and 400, you see it equals 841, which does not equal 784. So therefore, those side lengths do not form a right triangle. If you go over here, similar setup, we knew that the 1.25 would have to be the hypotenuse. So I do 1 squared plus 0.75 squared equals 1.25 squared. Simplifying and solving to find that the two sides do equal one another, so therefore it would be a right triangle. So this lesson does continue. There is going to be a part 2 of the lesson. The topic does change a little bit. So right now, guys, be ready for lesson 2, so part 2.